All right, so now we're ready to start using our probabilities, both theoretical and experimental, to start making some predictions. Kind of picturing, okay, this is how often it should happen, here's what I should expect if I were to do this in real life. So, to begin with our notes, we're going to start with our theoretical probability. That's what we practice first. We can use those theoretical probabilities to predict how often something's going to happen if we do a whole bunch of them. So we know that if we flip a coin, we know it's going to be a 1 out of 2 chance that you're going to get heads. But we want to know, what if we did a whole bunch of times, how many times would we expect? So again, it might not be exactly what would happen if we did it, but it's just a prediction. And the way to do that is to use a proportion. Take our original probability. So we want to know, if you were to flip a coin 100 times, how many times would we expect to get heads? So start with heads. There's a 1 out of 2 chance flipping a coin that we would get heads. What we want to know is how many times out of 100. So we're looking for this missing piece. So we start with our probability, our theoretical. Then we set up our other fraction over here, our other ratio. The total number, it goes on the bottom, and we want to know the top. Now, obviously, this one's a pretty easy one. We can probably do it in our head. But if we remember to solve a proportion, we just multiply along our diagonals. We do our cross products. 1 times 100 is 100. 2 times x is 2x. And then we solve to get x by itself. And we find out that we would expect 50 times, or 50 times we would get heads if we flipped a coin. That would be what we would expect to get. So let's try another one. Suppose you roll a 6-sided die, so a regular die, 1,000 times. How many times would you expect to get a 6? Well, start with what we want. What's the probability of rolling a 6? Well, there's one way to get a 6 out of 6 possibilities on a die. We want to know how many would that be out of 1,000. So the 1,000 goes on the bottom because that's our total, just like the 6 was our total number of possibilities. We want to know this piece. So again, to solve our proportion, we do our cross products. 6 times x is 6x. 1 times 1,000 is 1,000. And then we solve. Divide both sides by 6. So if I break out my calculator and I do 1,000 divided by 6, I get an answer of 166.666 repeating. Now, we're dealing with rolling a 6. You can't get a 6 2/3 of a time. So we would round this up to 167 times we would expect to get a 6. But we use that proportion to help us solve it. So let's try another one. Suppose you randomly draw a card from a standard deck of cards 50 times. So remember, a standard deck of cards has 52 cards. How many times would you expect to draw an ace? Well, again, focus on the probability of what we want. There are 4 aces, 1 for each of the 4 suits, out of those 52 cards. So we have a 4 out of 52 chance of drawing an ace. We want to know how much would that be out of 50 times. So we know there's a 4 out of 52 chance every time we draw. We want to know how many would we expect to get out of 50. So here's our missing number. We multiply along our diagonals, and we get 52x is equal to 200. Oh, sorry about that. Solve our equation. Yes, you have to show me your proportion in your work. And here we would get 200 divided by 52. And that would give me 3.84. And it's a big long decimal, so we'd round that up to 4. So that makes sense. If there's 52 cards in a deck and 4 of them are aces, if we were to do 50 draws, that means basically we're drawing almost all the cards from the deck, or the equivalent of a full deck of cards. We would expect to get 4 aces over the course of that time. So now let's go the other direction. Let's use our experimental probability. So we've done some trials or we have some data, we know some information, and we want to use that to make a prediction about what we would expect to happen in the future. So this one says last year a store sold 670 action, 580 comedy, 450 drama, and 300 horror DVDs. A media buyer, so somebody who's ordering for the store for the next year, expects to sell 5,000 DVDs this year. Based on these results, how many comedy DVDs should she buy? Well, last year they sold 580 comedy. To find our total, we add them all up. So 670 plus 580 plus 450 plus 300 gives us a total of 2,000 DVDs total last year. So this one is our comedy. This is our total. That's my experimental probability, what I actually have for information. I want to know how much would it be out of 5,000 DVDs. So if we were to sell more the following year, how many more comedies would we expect to sell? So let's solve our proportion. Multiply along our diagonals, do our cross products. So I get 2,000x is equal to 2,900,000. And then we divide by 200 to solve our equation. X is equal to 1,450 comedy DVDs. So if we continue to sell comedy DVDs at the same rate, at the same proportion of our total sales, going into that next year, we should expect to sell 1,450 of them. Let's see if we can do one more. Yesterday, 50 bakery customers bought muffins, and 11 of those customers bought banana muffins. If 200 customers come in tomorrow, so we have a really busy day, how much would we expect to sell for banana muffins? Well, start with the information we know. Out of 50 total, 11 bought banana muffins. So 11 out of 50. So this is banana muffins over total customers. We want to know how much would that be out of 200. So for some of you, you might see that you could just multiply 50 times 4, so we want to do the same thing up here. But if not, remember you can just do your cross products. 50 times x is 50x. 200 times 11 is 2,200. Solve our equation, divide both sides by 50. And we get an expectation that we would sell 44 banana muffins. So if we know we're going to be busy the next day, we know how many banana muffins to make in anticipation of selling about as many as we did the previous day based on the number of customers. So we're using that probability to help us find that new information. So let's take some information from a zoo. This frequency table, remember our little tallies that tally up how many people chose each one, of 70 zoo visitors were asked to name their favorite animal exhibit. What's their favorite one to visit? So 70 was our total, and this is the number of people who chose each of the different types of animal exhibits. Suppose 540 people visit the zoo. Predict how many people will choose the monkeys. So start with monkeys. Monkeys was 21 out of 70 total people in the survey. We want to know out of 540 people, how many would choose the monkeys. So we do our cross products. 70 times x is 70x. 21 times 540 gives me 11,340. Solved by dividing by 70. And we get 162 people would choose the monkey exhibit. So if it stayed at that same rate, 21 out of the 70 people, we would expect that 162 people out of 540 would want to go see the monkey exhibit or would choose the monkey exhibit. So we're using the data we have from a small trial to anticipate what we would expect from a larger one. So try the next one. Suppose 720 people visit the zoo. Predict how many people would choose the penguin exhibit. So for penguins, it was 13. So 13 out of 70 chose the penguins. We want to know how many out of 720. So we solve our proportion after we set it up. Yes, you got to show all that work. 13 times 720 is 9,360. Divide by our 70. And we would expect 133.7. So we'd round that up to 134 people would choose the penguin exhibit. So we're using one small set of data to predict, based on that same kind of comparison, that how much it would be for a much larger group of people.